the dissociation constant of an acid, and pH. A weak acid in solution will not dissociate completely. In fact, its dissociation will follow this formula, where Ka is the dissociation constant, H plus and A minus in brackets represent the concentrations of the dissociated ions, and HA in brackets is the concentration of the acid. Concentrations are always in moles per liter. pH is a measure of the concentration of H plus ions in a solution, and it has the following formula. The two formulas go together. The dissociation constant allows us to find the concentration of H plus ions in solution, and then we can find the pH. We solve this problem in two steps. First, we need to find the concentration of H plus to be able to find the pH. To calculate a constant and the associated concentrations, we generally need to use an ice table. However, this time it's not actually necessary, and here's why. The quantity of acid that dissociates, X, is negligible, so we can make the approximation that HA minus X is simply equal to HA. Note that this approximation is not always correct, and therefore the quadratic equation must be used to find the value for X. See Valerie's videos for a demonstration of this. The concentrations of H plus and A minus both have a value of X, so the product of the two will always be X squared. Keeping these approximations in mind, the ice table is unnecessary. Now let's see how to solve this problem. To find the concentration of H plus ions, which, like we just saw, has a value of X, we use this formula. Then we put in the values that we know. We are given the concentration of HA, which is 0.3 molar, and the dissociation constant, 1 times 10 to the negative 4. According to the approximations we made earlier, we can replace the concentration of H plus times that of A minus by X squared. Then we can solve for the value of X. We multiply the constant by the concentration of HA and then take the square root. We get a value for X, the concentration of H plus, of 0.005. To find the pH, we enter this value into the following formula and simply calculate negative log 0.005, which gives us a pH of 2.3. We know the pH right away. This allows us to find the value of the concentration of H+, which is also our value of X. We put the values we already know into the equation and solve for the concentration of H+. We do this by moving the negative sign in front of the log to the other side to get negative 4 is equal to log of H+, then by putting negative 4 as an exponent of base 10. Now we look at the dissociation constant formula. According to the approximations, we can also express the formula in this way. We know the concentration of HA, which is 2 molar. The value of X is equal to the concentration of H+, we found in the calculation of the pH. Therefore, we replace X squared by 10 to the negative 4 squared. We can then solve the equation and get a value for Ka of 0.5 times 10 to the negative 8.